It is indisputable the impact of the invention of nuclear energy fission was as transformative as when humans mastered fire. With war spreading across many regions of the world today, it seems that the risk of extinction by nuclear weapons is more imminent than ever. But are these weapons really as potent as we think? Some experts claim that nuclear weapons are not as lethal as we were made to believe, while other experts warn that a certain weapon can wipe out all life on Earth. What would a nuclear conflict cause to the planet? And what if we used nuclear weapons on something like the moon? Get ready as we investigate these questions and reveal the true power of nuclear energy weapons. Also, meet the bomb that is so dangerous that you hope one is never built. Nuclear warheads are the sovereigns of all bombs when it comes to weapons of mass annihilation. And according to recent estimates, there are about 12,500 nuclear warheads that are present in the world. Russia has about 5,900 and the United States has about 5,244 nuclear weapons. However, most of these nuclear weapons are stored or deactivated. In fact, both the United States and Russia have only about 1,600 active strategic nuclear warheads in service each. Still, that's 3,200 nuclear warheads, capable of causing a lot of destruction. Other countries officially recognized as nuclear weapons holders are China, France, and the United Kingdom, but their numbers are much smaller. For example, China has only about 500 nuclear weapons in operation according to the United States Department of Defense. The specific details of nuclear weapons, including their capabilities, are obviously secret. What we know is that the most powerful weapons have about 1.2 megatons, which corresponds to 1 million tons of conventional explosives, such as artillery shells, grenades, and air bombs loaded with TNT. Most nuclear missiles or ICBMs can carry 6 to 8 independent nuclear warheads with an average power of 400 kilotons each. But there were much more powerful and devastating bombs. You probably already know the famous nuclear device, Tsar Bomba, also called Big Ivan sometimes by now. But there may be a few things you didn't know about this impressive nuclear device. We all know that it was the most powerful nuclear weapon ever manufactured and tested on Earth, generating the largest man-made explosion ever recorded in history. New studies and observations estimate the power of the Tsar Bomba explosion at 57 megatons, or the equivalent of 57 million tons of TNT. It remains unmatched in its destructive power, but also in its uselessness. The bomb was useless because it was too big and heavy to be transported to be considered a practical weapon. Producing such a weapon in 1961 was a huge undertaking, literally. It was so big that a Tupolev Tu-95V bomber had to be modified by removing the bomb bay doors and fuel tanks from the fuselage just to carry the 27-ton bomb. It measured impressive 8 meters and almost 2 meters wide. The interesting thing, besides the size of the Tsar Bomba, is that it was designed to be a bomb with a capacity of 100 megatons. It was a 3-stage hydrogen bomb that used a fission-type atomic bomb as the first stage to compress a second thermonuclear stage, which in turn compressed a much larger third thermonuclear stage. And the evidence shows that the Tsar Bomba used several third stages, not just one. It could produce more than 100 megatons, but the bomb had a dampened design that involved a tampering. One way to reduce the radioactivity generated by the bomb is to use an optional layer of dense material that surrounds the fissile material. To reduce nuclear fallout, the third stage had a lead layer instead of a fusion layer of uranium-238. If the bomb had a uranium-238 layer, Big Ivan would have generated a power greater than 100 megatons. This is because of the uranium layer greatly increases the reaction by fissioning uranium atoms with fast neutrons from the fusion reaction, greatly increasing the intensity of the explosion. But by using a lead layer, fast fission was avoided and thermonuclear fusion was responsible for 97% of the Tsar Bomba's power, which means a much cleaner and smaller explosion. In fact, the bomb did not produce as much nuclear radiation because of the lead layers. The smaller explosion also allowed the pilot who dropped the bomb to get away far enough to survive the explosion. However, the explosion was still gigantic. The bomb was dropped over Mytyushika Bay test site, on the uninhabited island of Novaya Zemlya, and exploded 4 kilometers above the ground. It produced a huge mushroom-shaped cloud over 60 kilometers. The glow of the detonation was seen 1,000 kilometers away and was able to cause third-degree burns in anyone within 100 kilometers. It would definitely have been visible from Earth's orbit if there was any astronaut to see it. But in the end, the Tsar Bomba had no other strategic value besides intimidation, but not it intimidated anyone because the American scientists pointed out its size, and that fact alone made it strategically useless. Moreover, the tests show that a 100 megaton bomb releases only 10 times the energy of a 10 megaton bomb, but does not cause 10 times more damage. This has to do with the non-linear blast effects of the explosions. Therefore, a 100 megaton explosion is only a little more than twice as damaging as a 10 megaton bomb. But on the other hand, the weight of nuclear weapons is scaled approximately in a more linear way. A 100 megaton bomb weighs 10 times more than a 10 megaton bomb, making it much harder to deploy on a missile or bomber. Since then, nuclear weapons have lower powers and have been more deterrents to nuclear war. But lately there has been some nuclear saber rattling by some individuals. The chances of the start of a nuclear war could be a reality. In fact, the doomsday clock is currently set to 90 seconds to midnight, the closest it has ever been set to midnight since it was created. So, what kind of damage could a nuclear attack cause? What are the nuclear weapons the two countries that have the most of them have? There have been some new missiles in the headlines lately. The Russian Federation has the intercontinental ballistic RS-28 Sarmat missile, dubbed Satan II after the previous R-36 or SS-18 Satan ICBM. The RS-28 Sarmat can carry 15 light nuclear warheads or several re-entry vehicles, called MIRVs, and each one is capable of gliding and hitting a different target. The LGM-35A Sentinel is the latest generation intercontinental ballistic missile of the United States Air Force missile, taking the place of the 5-decade-old Minuteman III. The Sentinel can also carry multiple warheads, such as the 475-kiloton thermonuclear W-87 warhead previously deployed on the ICBM LGM-118A Peacekeeper. The fact that all these ICBMs can carry multiple warheads means that the chances of surviving the explosions and the ensuing nuclear winter will depend on where you live, and how fast you can hide in a nuclear shelter. In a total nuclear attack, there are many different factors involved to predict exactly what would happen, such as knowing how many missiles could be shot down from each side. But as hypersonic gliders are extremely hard to shoot down, the damage would probably be catastrophic for both sides. But one thing is certain, no matter who starts a nuclear war, there will be no winners. One side launches nuclear missiles and the other side detects the launch and retaliates with its own nuclear attack before impact. Ballistic missiles from submarines of both sides are launched. The first thermonuclear attacks create electromagnetic pulses that burn electronics and power grids. The next targets are command and control centers and other nuclear launch sites. All land-based ICBMs take 30 minutes after launch to reach their targets. Each nuclear warhead that managed to get past the air defenses would explode with a fireball almost as hot as the core of the sun, followed by a shock wave that would vaporize anything in its path. Any survivors in areas not directly affected by the explosion would have to deal with firestorms and high levels of radioactivity. But the worst would still be to come. All the black carbon smoke from the nuclear explosions, and the firestorms they created, would end up high in the stratosphere, where high-altitude jet streams would spread it across the skies. Some studies say that this black smoke and dust would create a nuclear winter, and cool the planet by 20 degrees Celsius. Without supplies, these still living people would end up starving or perishing due to the effects of radiation sickness. In fact, we have no idea how many survivors there would be in a nuclear war, but could all this destroy the planet? How to break and actually explode? There is no possibility of destroying the Earth. Even the Tsar Bomba was nothing when it came to what planet Earth can withstand. The estimated yield of the Krakatoa volcanic eruption in 1883 was the equivalent of 200 megatons of TNT, 4 times the yield of the Tsar Bomba. The eruption sent 21 cubic kilometers of broken rock into the air. The volcano spewed out a black cloud that spread across the sky, leaving the Earth completely in the dark. The ashes of the explosion almost reached the edge of space, about 80 kilometers, and filtered enough solar radiation to lower global temperatures by almost 0.5 degrees Celsius for a whole year after the eruption. And nothing made by man can even come close when we compare it to the largest explosion that ever happened on Earth, the Chicxulub impact event. The Chicxulub asteroid that collided with the Yucatan Peninsula, in Mexico, about 66 million years ago, was thought to be between 10 and 15 kilometers wide. But it was traveling so fast, about 72,000 kilometers per hour, that the impact formed a crater 150 kilometers wide. The estimates show that the kinetic energy yield of the asteroid on impact was about 72 teratons, equal to 72 million megatons. And do you think our insignificant nuclear weapons could explode anything? Even if you could somehow put all the nuclear weapons on the planet in a pile, and detonate them all at once, it would not cause anywhere near the same damage as Chicxulub did. We are talking about an explosion equivalent to the explosion of 2 million Tsar Bombas. Despite the huge impact and explosion almost destroying all life on planet Earth, the planet will still be spinning and full of life. In fact, the Earth has already faced many asteroids, volcanoes and earthquakes that make our most powerful nuclear weapons look insignificant in comparison. And the Moon? Could we destroy our satellite if it ever threatened our planet like in some of those silly movies? Let's not forget that the Moon is 1/4 the size of the Earth with a diameter of 3,475 kilometers. If you fired all the nuclear weapons at the Moon, it would shrug them off as if someone was throwing a handful of stones at it. So forget about blowing up the planet, or the Moon, with nuclear weapons. But there is a weapon that would probably end all life on planet Earth, if this doomsday device ever was designed and used. It is a terrible weapon known as a cobalt bomb. We have seen some other sources suggest that cobalt increases the nuclear yield. Well, that is not the truth. The truth is actually more horrible. Because what it lacks in energy in the explosion, it makes up for in radioactivity. This bomb is also known as a salted or dirty bomb that rains huge amounts of radioactive material over a wide radius after the explosion. In other words, if the explosive fireball and shock wave did not hit you, the increased amount of radiation will. Its concept was originally described by physicist Leo Szilard in 1950. He was not proposing that such a weapon be built, but instead describing that nuclear technology will soon reach the point of ending all human life on Earth. In other words, a true doomsday device. So, how would this doomsday device work? Remember how we talked earlier about the lead tamperers of the Tsar Bomba in the video? They were the ones that made the explosion cleaner when it came to the radioactive fallout left behind. A cobalt bomb would do the opposite, having a tamper made of common cobalt placed around a thermonuclear bomb. When the bomb explodes, the intense neutron flux from the explosion converts the cobalt into deadly cobalt-60, which is then vaporized by the explosion. This vaporized cobalt would condense and fall back to Earth with the dust and debris from the explosion, contaminating everything it touches. Even if you escaped and hid in a radioactive shelter, a high-energy gamma radiation, the cobalt-60 emitter has a half-life of 5.27 years. That's a long time to wait for it, and everything around you, to decay. Maybe some creatures like tardigrades, or even cockroaches, can survive. But it would be unlikely. Imagine if the Tsar Bomba had a cobalt tamper in its multiple 3 stages in the design. A cobalt tamper would have caused the bomb to produce a huge amount of radioactive fallout, which would have spread over a much larger area than the fallout produced by the lead tamper. This huge amount of radioactive fallout would have caused widespread environmental devastation, including health problems for all people on the planet. These are scary things to imagine. We all hope that no one ever designs such a weapon, but more importantly, that no one ever uses nuclear weapons. As we said before, there are no winners in such a war. That's all the time we have for now. But before we go, we want to know what you have to say, and what you think about the subject. Will someone finally push the button one day, or will humanity be smarter and survive self-annihilation? Let us know in the comments. Stay tuned here for more fascinating stuff, and thanks for watching. Like and subscribe to our channel.